Hi guys, welcome to today's lesson. Today we're looking at the area rule for non-right angled triangles. Now, of course, if we had a right angled triangle like this, you'd say straight away, so it's just half times the base times the height. Okay, we know that, right? Now, I'm not going to go the ins and outs on how to find this rule. Okay, we don't have time for that, but certainly later on, if you want to investigate it, you're most welcome to. The problem is going to be we might have a question that looks like this. Okay, and no longer is there a perpendicular height or a 9-degree angle, so we can't use that rule. So we need to use a second rule. So of course, that's what we're looking at with non-right angled trigonometry. Now, like before, I'm going to give you a nice little generalized triangle here with our lettering. Good thing to write down. And our rule will look like this. Area equals half A times B times sine C. Now, that's one version of our rule, where it uses two sides and one angle. I could have said something like this. Area equals half times B times C times sine of A. I could have even said this. Area equals half A times C times sine of B. Now, there are lots of ways that we could do this, okay? Lots of ways we could do this, you can see. Now, of course, you could use a formalized rule and figure this out, but we want to be able to use this for any situation. So can you look at those three rules and figure out what's going on? So if I look at the very first one, half A times B. Well, A and B are these two sides here in red, and angle C sits inside there. Interesting. What if we looked at the green one? Half B times C, so we'll do in green, B and C, and then sine of A. Let's use alpha. Well, that's interesting. And what about the last one? A and C in blue times sine of B. We use that as beta. Can you sort of see what's happening here? When you're looking at the area of a non-right angled triangle, we are looking at the two adjacent sides, and we call it the included angle. It's the angle that sits in between those two sides. So for the blue one, the beta one, you can see we've got the two blue sides and my angle sits in between them. So that's really important when we're looking at these sort of questions. So let's look at this question here. I'm going to write the rule down so we've got it there. You might want to actually pause it because it's not that hard, to be honest with you. I'm going to use AB and sine C. If you want to have a go at the question, as I said, pause it and have a crack and see how you come up with. Now, in this question, for this particular one, there's really not much you can do wrong. Because, to be honest, if we look at this rule, we have A and B, which are two sides. So we've got 8 and 6. And then we have sine of C, which is where C is an angle. We only have one angle there. Like, you can't go wrong in this style. Later on, yes, when you have more than two sides and more than two angles, yeah, you might have to make some choices there. But in this case, it's nice and easy. They love doing these questions here with exact values too. But of course, we have sine 70. We can't do an exact value with this question. But if it was sine 60, 30, or 45, yes, we could. Might even look at that later on if we have time. So in this question, gents, we're simply going to do, we're going to do half times 8 times 6. Okay, you can do that lots of different ways, of course. And we're going to do times sine of 70. Just be careful. The only little mistake I see people make with this question is they don't use sine. They might use cos, for example. There's a certain question which we'll look at and that becomes evident why people do that. Okay, so we have 22.5526229 ... Now, of course, this is meters. It says for two decimal places. So area equals 22.55 meters squared, and that is my answer. It's as simple as that. It's not that hard. Again, you are generally given that rule there, so that's fine. It makes it a little bit easier, but you should be able to know this rule off by heart as well. I want you to learn these, particularly being the higher echelon students. You should know these rules off by heart. Practice makes perfect. That's a pretty straightforward, easy question. And a lot of them you'll see, particularly in the Year 10 papers, will be like that. They'll be very straightforward. However, this is this question. Now, this is the one we see in hard 5.3, 5.4 examinations, or in fact, HSC exams as well. Advanced maths used to love having this question in there. It would simply say, find the area below. Now, can you see the biggest problem with this question? Well, hopefully you're yelling at me saying, sir, there are no angles. So if I write down my little rule of half A times B times sine C, well, we have three sides to choose from for A and B, but none of them have an angle. So we get a bit stuck. So I wonder if you can think of a way to find an angle. So in this instance, you might say, well, what if I put an angle there for theta? What perhaps could we use in order to find that angle? Well, it's a non-right angled triangle, so we look for the sine rule. There's no angles at all, so we can't use the sine rule. So can I use the cosine rule? Well, we have the opposite side. We have three sides, in fact, and we have an angle there that we're trying to find. Yes, we can. So the first thing we're going to do is find that particular angle. So I'm going to write this down. Cos theta equals, now remembering the 7 is opposite, that's the one that we'll be subtracting in the rule. So we can do 8 squared plus 10 squared, subtract 7 squared, all over 2 times 8 times 10. Now that will generate a response for what cos theta is. Of course, we need to figure out what theta is. We'll be doing shift cos at some point. You can do it straight away if you feel comfortable. But I'm just going to do it bit by bit, so we're making baby steps. So I'm going to type in my 8 squared plus 10 squared. Remembering it's the most important part is you're subtracting the side that is opposite the angle that you're looking at. Okay, and then of course on the bottom there, we're having 2 times 8 times 10. I'm just going to go back up because my 8 wasn't squared. Be careful you enter it in correctly. Okay, so I end up having as a fraction 23 over 32. Or I might put in 0.71875. Now again, I must see that first line. I don't really care about the second line. It might help you because a lot of people like doing this. Cos -1, cos -1 outside of 0.71875. You want to show all the working, by all means go for it. But I like the cos -1 because it helps you remember to press shift. Because of course, 0.718, it's a very unlikely angle. It's not impossible, but it's unlikely. I'm going to do shift cosine and then do my answer button. We get theta equals 44.04862567 ... Now, that's what my angle is. Now, what a lot of people will say to me, so does it matter which angle you find? What if I found, let's say, alpha at the top there, or if I found beta down the bottom here? Would it really matter which one I found? The answer is absolutely not. Because we're going to use that to apply it to our area rule. All it would make a difference of is which of the two sides, this A and the B, that I'll be using. Now for me, my area rule will say A and B. Well, my 44, is that rectangle there, which means my sides are directly next to it, happen to be the 10 and the 8. If you found alpha as your angle, you'd be using 10 and 7. If you found beta, you'd be using 8 and 7. Just be very careful which sides you're using. So for me, I'm doing half times 8 times 10 because they are either side of my theta, okay, times 44.0486 ... Now again, very important, use your answer button, okay, because we want to make sure we use that whole number. We don't want to round it to 44.0, for example. Don't want to round too early. So now I can type my calculator, 0.5 multiplied by 8 times 10 times, now this is the important part. Look what I missed off there. Sine. A lot of people have just, because you've used cosine rule, you'll use cosine again, and you be really careful. Area rule uses sine. Be super, super careful there. Sine, and I'm going to do my answer button. So again, I've done my half times 8 times 10 times sine of the angle I just found. I now press equals, and we get 27.8107 ... I look at my question, it says 3 sig fix. So A equals 27.8 centimeters squared. Remembering again, we are finding area of that particular triangle. Now for me, that's probably one of the hardest questions that you'll come across because you weren't given an angle. So you had to go and find the angle. Again, it doesn't matter which angle you find, just depends on the two sides that you're using. They have to be the two sides with the included angle between them. That's really important. Apart from that, it's not really that hard. The only other question I guess you get something like this, and because we've got a bit of time, I might throw this one in, e.g. 3. Okay, so EG3, let's make this one up on the spot. Let's do something like this. We'll do that. We'll do 30 degrees. We'll do 14 centimeters, and we'll do 15 centimeters, and it says to find the exact area. Okay, now this is a hard question I can kind of think about at the moment, and that's because I'm using this word exact, which means that we are going to use exact values. We actually can't use cos on our calculator or sine on our calculator. Now, in this instance, we're going to say, well, depending on the question, of course, you might be lucky, maybe. And I reckon you probably will be. Let's actually change this to 45. I want to make sure I don't get a nice answer like of a half, for example. Okay, 45 degrees. So we know that we're going to get half times 14 times 15 times, it's the area rule, so sine of 45 degrees. Now, of course, we know that half of 14 is 7 times 15, okay, 105 or thereabouts. We can do that part in the calculator. But this sine 45, the minute I do sine 45 in my calculator, it's going to round it. We don't want that. So I'm going to come back down to my triangle, which is my isosceles right angle triangle of 45 and 45, 1, 1, and root 2. And I'm going to say that sine 45 is equal to 1 on root 2, our opposite over hypotenuse. So I can now say a half times 14 times 15 times 1 over root 2. So of course now I can, if you hadn't done that in your head before, you could do half times 14 times 15, or you can do 7 times 15, whatever you might want to do. Okay, and we get that 105 times 1 over root 2. Let's just do it over root 2. And technically speaking, that now becomes my answer. Okay, now I hope a few of you might be yelling at me and saying, Mr. Pay, that's not rationalized. So technically speaking, it's not simplified. So we might like to rationalize that by timesing it by root 2 over root 2 and making it into 105 root 2 all over 2 centimeters squared. And that would be certainly a nicer way to write that, having a rational denominator. But that's the only other really hard question I think I can come up with in terms of the area rule. So once again, just to reiterate, my rule says area equals half AB sine C. Okay, making sure that the two sides has the included angle in between them. That's the most important part. And then obviously answer the question as you see need fit. Hope you're having a great day and great time down there. I'll speak to you soon. Have a good one.